Assalamu alaikum dear students. Today we are going to discuss another application of derivatives, that is to find the approximations, how differentials are used in finding the approximation of certain quantities. Approximate value is that value which is not equals to the exact value, but it lies very close to the exact value. That is, it may be slightly less than the actual value, or it may be slightly greater than the uh, exact value. So here we have to simply find those approximate values or those approximations. Now if we consider a function whose domain is set of real numbers to or defined by defined by f of x, that is y equals to f of x. Now let us assume that its graph is just like this. Now if we consider a point on its domain, let's assume that point is x, then the corresponding point in the codomain, that is in the range, is y, which is f of x. Hence this point on the graph is x and y, or x f of x. Now if we give a small increment in x, that is, if we change x from x to del x, that is considering the neighboring point of x, that is x plus del x, then the corresponding change or the corresponding value of the in the codomain is given by this x plus del x comma y plus del y, where y plus del y is f of x plus del x. Now if we subtract these two equations, this equation from this very equation, we simply get del y equals to f of x plus del x minus f of x. Since we know that in the limiting case del y upon del x equals to differential, that is dy by dx, so we define differentials as dx equals to del x and dy equals to f dash of x dx, or simply dy equals to dy upon del x into del x. Here you know that in graphically, if we have a point this xy, if we draw a tangent at this point, now you know that when we draw a tangent, this tangent will cut this triangle at a point, let's assume that here, at a distance of dy, at a distance of dy. So this means that this dy is the approximate value of this del y. This dy is the approximate value of this del y, because here del x equals to dx, del x equals to dx, and dy is slightly less than del y. Hence we can treat this dy as the approximate value of this del y. That is, dy is the approximate value of this del y. Like if we consider an example to find the approximate value of the under root of 25.3, let's take y equals to under root of x, where x is 25 and del x is 0.3, that is 0.3. Now when x equals to root x, which implies that del y equals to under root of x plus del x minus root x, because y equals to root x, y plus del y equals to under root of x plus del x. Now subtracting these two, we will get this very expression, this very equation. Here del y equals to, here x plus del x is 25, del x is 0.3, which implies that x plus del x is root of 25.3 minus root x, that is minus root 25. Root 25 is 5. This is root of 25.3, or simply 25 root of 25.3 is del y plus 5. Name it equation first. So the value of this 25.3 equals to del y plus 5. Now we have to find this del y. What is the del y? Since we know that the approximate value of this del y is dy, and this dy is given by f dash of x into del x, f dash of x into del x, or simply if the function is in y, we get dy upon dx into del x. Here y equals to root x, which implies that dy by dx is 1 upon 2 root x. Hence this equation becomes del y is approximately equals to dy equals to 1 by 2 root x, because this dy by dx is this into del x. Now x is 2 root x is 5, which implies that 1 by 2 root 5 into 0.3. After simplifying this number, we get 0.03. So this means that dy equals to 0.03. Hence substituting in first, root 25.3 is equals to 0.03 plus 5, that is 5.03. So this is not the exact value, because dy is not equals to del x, and this del y, and we treat a dy as the approximate value of del y. Hence this 5.03 is the approximate value of 25 under root of 25.3, because the exact value of this root 25.3 is 5.09910 onwards. So this is the exact value and this is the approximate value. In this way we use the differentials to find the approximate values of the given quantities. Now let me consider another example, like find the value of 0.999 whole raised power 1 by 10th, that is 10th root of 0.999. Let y equals to x raised power 1 upon 10, where x is 1, del x. Now because subtract 1, we have to select x in such a way that is x plus del x should become 0.999, which implies that we have to put del x as minus 0.001. Now here x plus del x whole raised to power 1 by 10 is 1 minus this very quantity whole raised to power 1 by 10, which is 0.999 whole raised to power 1 upon 10, which implies that y plus del y equals to x plus del x whole raised to power 1 upon 1 by 10, whole raised to power 1 by 10, which implies that subtracting this equation from this, we get del y equals to x plus del x whole raised to power 1 upon 10 minus x raised to power 1 upon 10. Now this x plus del x is whole raised to power 1 by 10 by, we calculated this very quantity as 0.99 whole raised to power 1 by 10 minus 1 raised to power 1 by 10. Now 1 raised to power 1 by 10 is 1. Now when we shift to this side, which implies that 0.999 whole raised to power 1 upon 10 is del y plus 1. We know that the approximate value of this del y is dy, which implies that 0.99 whole raised to power 1 by 10 is approximately equals to dy plus 1. Now dy is dy upon dx into del x. Now substituting the values of dy by dx by differentiating y equals to x raised to power 1 by 10 and put x equals to 1, we simply get minus 0.0001. So from equation first, 0.999 whole raised to power 1 by 10 is approximately equals to minus 0.0001 plus 1, that is 0.9999. So this is the approximate value. Like in functions, if we consider an example, find the approximate value of 2.01 where f of x is, find the approximate value of f of 2.01 where f of x is 4x squared plus 5x plus 2. If we put x equals to 2, choose x, such a number which is easily to simplify, which implies that del x is 0.01. Now f of x plus del x is this very quantity, which implies that del y is f of x plus del x minus f of x. Now x plus del x is 2.01, that is this, and f of x is f of 2. Now f of 2 is obtained by putting x equals to 2 in given function, which is 28. Hence f of 2.01 is del y plus 28. Now approximate value of this is dy plus 28, which implies that we have to find this dy, and dy is f dash of x into del x, that is 8x plus 5, because f dash of x is 8x plus 5. and to del x, that is 0.01. Now this 8x plus 5 at x equals 2 is 8 into 2 plus 5 into 0.01, that is 0.21. Hence from equation first put dy equals to 0.21 in the first, f of 2.01 is 0.21 plus 28, that is 28.21. Hence 28.21 is the approximate value of this very quantity, that is f of 2.01. In this way you can find the approximate value of the any type of function. So inshallah from tomorrow's video lecture we will start another chapter, that is indefinite integration, simply the integration. So thank you.